What's up, Chem fam? This is Lit Chemistry, where theory meets excitement and concepts spark with clarity. Hybridization is the concept of mixing atomic orbitals of similar energy to form new, equivalent hybrid orbitals that are better suited for chemical bonding. So let's start with the basics. Let's quickly understand what 1s, 2s, and 2p actually mean in an atom in the simplest way. Shells. So, what are shells? An atom has energy levels called shells. For example, like floors in a building. For example, first floor, second floor, third floor, fourth floor are the shell numbers. Orbitals. In each shell, electrons stay in rooms called orbitals. For example, we have s orbital as a round room and p orbital as dumbbell shaped room and d orbital as double dumbbell shaped room. D orbital always has a higher level. Next, I am going to explain about the notation 2 and 3 notation. So we have notation where 1s2, 2s2 and 2p2, 1s2, 2s2 and 2p2 is called the electronic configuration, in which the first one 1s2, where 1 is called the shell, s is called the orbital, and 2 is denoted as electrons. In the same way, in 2s2, 2 is called shell and s is orbital and 2 is denoted as electrons, same way. And again in 2p2, 2 is the shell, p is the orbital and 2 electrons. Fourth one, naming. So the whole thing 1s2, 2s2 and 2p2 is called the electronic configuration of carbon. So let's start with the structure of methane, that is CH4. For 3 marks in exams, usually they expect us to write 3 important statements, such as in methane, all carbon atoms undergo sp3 hybridization. In methane molecule, carbon forms the central atom. It undergoes sp3 hybridization. The electronic configuration of carbon in its ground state is 1s2, 2s2, 2p2. So we have 2s orbital and 1s2 is not included because it has lower energy and it does not mix. So 2p orbital, there are 3 squares, and in 2s we have 2 electrons, and 2p also we have 2 electrons, 2s and 2p. Next it undergoes unpairing and promotion, where promotion of 1s orbital to 2p orbital, 1s orbital to 2p orbital. So in 2s we will be having only one electron while it pass from here to there. Yeah, one electron. In 2p we will have 3 because plus 1, 2s and 2p. So the next step would be hybridization, and where 1 2s orbital and 3 2p orbitals combine together. So 2s and 2p, 1 2s and 3 2p would be, first we have 4 electrons. So the 4 hydrogen atoms adds on and it becomes 4 sp3 hybrid orbitals. So this part is called as the ground state and this part is called as the excited state. So at the end we write a important statement In methane molecule, the four hybrid orbitals overlap with the 1s orbitals of four different hydrogen atoms, giving methane molecule. So we have the geometry that is tetrahedral, and bond angle has 109 degree 28 minutes. We have the orbital structure of methane, that is this diagram, which has four hydrogen atoms, and this is called the sp3 orbital, and this is called as the s orbital. So this much is very important for 3 marks in hybridization, usually for exams. Next we have is the hybridization of ethene, that is CH2 double bond CH2. So first we write the 3 important statements. In ethene, carbon atom forms the central atom and they undergo sp2 hybridization. The electronic configuration of carbon in its ground state is 1s2 2s2 2p2. Why it is 1s2 2s2 2p2? Because the atomic number of carbon is 6. The atomic number of carbon is 6. So hence it is 1s2 2s2 2p2, 2 plus 2 plus 2. So the first step we have 2s orbital, 2p orbital. Then 1s we do not use because it has lower energy. In 2s we have 2 electrons and 2p we have 2 electrons. Unpairing promotion, 1 electron jumps from 2s to 2p, promotion of 1 s orbital to 2p orbital. So we have 2s where there is only a single electron left, and 2p there are 3 electrons now. Next step is hybridization, and since it is sp2 hybridization, so only one s orbital and 2p orbitals are taken. Since it is sp2, so 1s orbital and 2p orbitals are taken here. So 1s orbital and 2p orbital, it becomes 3 sp2. So electrons are filled and it becomes 3 sp2 hybrid orbitals. So 1 electron remains in 2p, that is written here 2p, and we write 1 electron. So finally, as we conclude, we write ethane molecule formed contains 1 sigma and 1 pi bond between carbon atoms. So the geometry will be trigonal planar and bond angle will be 120 degree. So orbital structures will be carbon, there will be 2 carbon atoms and the structure will be something like this. Here there will be hydrogen atoms, 4 hydrogen atoms because it's ethane. Here it's called sp2 and these are called as pi bonds. Now we have the structure of ethine, that is CH triple bond CH. We write the 3 statements. In ethine, carbon forms the central atom. It undergoes sp hybridization. The electronic configuration of carbon in its ground state is 1s2 2s2 2p2. Now we start. We have 2s orbital, 2p orbital. In 2s we have 2 electrons, in 2p we have 2 electrons. Unpairing, then promotion takes place, promotion of 2s orbital, 1 2s orbital to 2p orbital. So we have 2s and 2p, where one electron is promoted to 2p. Next step is hybridization, where we have to transfer one s and one 2p in order to get sp, 1 2s plus 1 2p orbital. So we'll be having only 2 sp hybrid orbitals. So in conclusion, we write, in the ethine molecule, two pi bonds and one sigma bond are present between carbon atoms. The geometry and bond angle geometry will be linear and bond angle will be 180 degree. So now we write the orbital structure where two carbon atoms are the central atoms, and the structure will be something like this. Here we have two hydrogen atoms attached, and these are called pi bonds. At the edges we have two hydrogen atoms attached.